Meeting is being recorded.
Okay, welcome everyone to this week's OMR Architecture Meeting. So this week we have a continuation from a topic that we discussed last week. So Erwin, after last week, Erwin went away and did a number of experiments with the memory hierarchy in the compiler, and he's going to report back on what he's found this week. So take it away, Erwin.
Okay. So I was initially going to first only touch the raw allocator and deal with the problems that Mark was saying he ran into. But then I sort of figured I'll just go all the way and just try and get something working. The approach I took was, in order to deal with some of the concerns that were brought up before, I essentially made it so that it's the same number of delegations that happen anyways right now. So it was a relatively simple one-to-one mapping between the existing allocators and in this new world, minus the segment pool, which no one's using, and we should probably just remove that code anyways. So for the most part, I was a little surprised it all worked, but it does. I'm able to run both J9 and OMR, no problems. I did have, and I put the links to my commits on the issue. The things I ran into were, and I listed them out as tasks we should do. If we're going to go down this road, the smaller tasks that we were talking about in terms of what can we do for this, we definitely want to change the code that passes these allocators by value, specifically the raw allocator and the TR allocator. The TR allocator particularly bad, because I thought we were passing it by reference, but we're not, and I don't know if it's okay not to pass it, not to make a copy of it, because the TR allocator is a CS2 allocator that, when you create a new one, takes the base allocator as the thing it's going to use to allocate memory, but it also has its own segments that it keeps track of and stuff. And I was like, okay, if I change it to just use the one allocator that the comp object has, I don't know if that affects performance or not. So that's something that's a different.
Do you think of any reason why we would have passed it by value in the first place?
No. No, I don't. I was genuinely shocked. I thought it was done, and then the compiler started complaining about all.
Have we always done it? Do you know if we've always done it that way, or was it when we re-architected this a couple 3 or 4 years ago, it was changed to be by value?
We never needed. We weren't using STL before, so we never had TR allocator. We were doing shared allocator directly. That we then loop wrapped it up in the comp allocator call, which returns it by value, which was extremely frustrating because it required a lot more changes that I had to do than necessary. And the raw allocator, same thing. The raw allocator at least makes a bit more sense because in the old way it was stateless, and it's still stateless, sort of, but it's a hierarchy, so it has a VFT and stuff. But before it was essentially just, it didn't matter. One raw allocator was the same as another raw allocator because it was a wrapper around malloc. So that was annoying, but at least that made sense. And then in order to get the last thing we should do, so one is change all the raw allocators to be passed by reference. Second one is change, even if we don't go down this road, it's just nicer to pass it by reference. Second one is pass all our TR allocators by reference. Third one would be update the typed allocator to actually use references. It'll just make life easier if we go down the road, because if we ever change even if we don't go down this way and we say, you know what, we want to make things have better guarantees, it'd be nice if the allocators were all, or just were references. And again, like the scary part was it built. It's just when I ran, it would crash because when I changed typed allocator to take a reference, it had a reference to an allocator that was on the stack that died. So crazy things like that is what we don't want to happen. All of the complexities I ran into were all OpenJ9. OMR was surprisingly just easy and clean. And they're mostly all the issues that Mark ran into. They all came from the fact that J9 J9's backing allocator, as in like the VM that provides the J9 memory segment. But this whole mechanism was everything is a TR memory segment. And so I listed out the decisions I had to take as a consequence of it. For the J9 memory segment approach, I deviated from how Mark did it, but essentially Mark ran into the same problem when I was talking to him. I just sort of kept it as dumb as possible. I just extended TR memory segment, and then essentially the consequence is that the Java core will say, oh, you used up the entire memory segment, but really you might not have. But at 16 meg segments, you'll be off by 16 megs. I don't think it's terrible.
Who counts 16 megs?
Yeah. Well, I mean, 16 megs of, yeah. I mean, it depends. It might matter. It might not.
Side comments like that. Oh, sorry.
But essentially,
we never want to lose snide comments.
But essentially, because of the proof of concept, I was taking a bunch of just decisions that I was like, I know this won't fly in any real design, but just to show that it works, I didn't want to get bogged down in all these tiny details that come up in J9.
Mistake I made.
There were a couple of other unfortunate decisions, like the destructors had to know, like the API says it has to be a TR memory segment, but in J9 it kind of had to know that it was actually the child type. And again, it was encapsulated in one file, but it's still sort of unfortunate. Same with the raw allocator. It had to know that the allocator you're passing in to copy construct from, even though the type was the API type, will actually be a very specific type. And you better get that right when you're compiling or writing code. So there was that. And then the last one was just the persistent allocator was mostly fine, except for the fact that now that in this prototype, since I switched it to all be TR memory segments references, what the old approach did was that it would say, do I have an existing segment that I can reuse to fulfill? Oh, sorry, do I have an existing segment that I can use to fulfill the request that's being made right now? Mm-hmm. And if there wasn't, it would just return null. And then if it was null, it would allocate a new segment. That doesn't work with references. So I've talked to Leo. It returns an iterator right now, which is not something I like because the iterator, it's fine in this world because in this particular case, because it's only being called there and the function is locked. But if anyone else inside there will use it without knowing, the iterator could be invalidated because the persistent allocator is global. And it's not, like, it's something that you have to be careful of. So those are the decisions I have to go through to make this work. But it does actually work, shockingly. I was expecting to see more crashes, but I'm not.
Is the thing that you have put together in a sane enough state that you could actually do performance runs with it? Like, would they be meaningful performance runs to get an idea as to whether or not there are problems with this approach?
I could do it.
Yeah, but would they make sense if you did?
Yeah, I think so. I mean, they're essentially the same. It's all exactly the same, actually. Like, I left all the heuristics the same. Nothing is actually different. They're like, you remember how when we first described the design, we were talking about having multiple delegation levels. In this one, we have the same number of delegation levels. The segment sizes are the same. How you choose to free it back to the VM is the same. Nothing has actually changed in any way. So I expect performance to be the same.
Okay.
That said, some of the decisions are less than ideal. And so even if we did performance runs, it wouldn't matter if, like, when we change the design up in some fundamental way, they affect performance. So I'd say it only makes sense to do a perf run when we're actually trying to do it properly.
Right. I guess the question is whether or not, if we have to do a lot of work to get to that point, mm-hmm. and then we realize, oh, the performance this isn't a great solution, we shouldn't have done it. We can answer that question now, or at least give us an indication as to whether or not.
I can try it, and hopefully there's no underlying bugs that I've missed in my proof of concept. I mean, I did one benchmark where there was a whole bunch of hot compiles and there was no bugs, so I'm thinking it's fine, but you never know. So I can try that out as just an experiment to see what happens. The thing I didn't do in this proof of concept was I didn't do what Mark needed and what Trill needs. And the reason is because I don't know which approach will be taken. Will it be that you want a standard class that encapsulates all of these layers, or will it be that the type dictionary and the method builder will take in an allocator? I don't know what the philosophy was, so I was like, you know what? I just sort of said, okay, if we switch to this model, it'll work. To fix that problem could be done in multiple ways, just the way it stands right now too. Like if you passed in an allocator, it would also work right now. It would be the same thing. So that's why I figured that's a different discussion. But it is the case right now that you only talk about a segment allocator ampersand or a raw allocator ampersand. That's it. Those are the only two classes you are ever talking about in the entire code base, except for very specific places. And so it's consistent on that point. I believe Ben did the code and he had some comments.
Yeah, mostly just to do with fields being of reference types, but I think that's something that could be fixed in revised design. It wouldn't change any performance characteristics or anything. It's mostly just it would mess up move assignment and copy assignment operators. So generally, it's not recommended to have fields of reference types in C++.
The other thing is that this, and maybe I should put up a diagram of how this prototype looks, because it doesn't match the original PDF that's put in there. So when Leo, me, and Devin were first talking, we sort of figured that we would implement the debug segment provider as, instead of using the malloc raw allocator, we'd use the debug raw allocator to allocate to mmap essentially. Except that doesn't work because when you deallocate, you don't want to munmap, you want to mprotect, and you want to deallocate separately. And so that wouldn't work with the existing setup. So I sort of said, well, just the debug segment provider would be another segment allocator. That's it. And it didn't have a backing provider. It just did the work directly. So I can put up an updated diagram of how this looks, which will map one-to-one exactly with the existing infrastructure. But it's easier to reason about in terms of names, and you can rename a bunch of the stuff. We don't have to keep the name. I kept the names the same because, again, I sort of just said, we'll simplify all the field names and all that stuff. But realistically, all the field names could just be changed to segment allocator everywhere. And it doesn't matter what the type is. The type is always, all the fields are all TR segment allocator reference. So, and in fact, it was actually very easy for me to construct some of these things because they all took a reference of segment allocator. So like literally build things around and nothing broke.
One of the things we talked about last time was if we were to go down this path, having the ability to have both the old and the new scheme coexist, perhaps with a build flag or something like that. Is that?
That's how it is right now, yeah.
Okay.
Everything is guarded by new memory.
Okay.
I can build both.
And then some changes would potentially be common, like passing the allocator by reference.
That has to be done first, but right now it's guarded.
But it would be common to both solutions.
It would be common to both, yeah. I mean, I don't know how you guys feel about this. I don't know if it's worth the effort to change all those things in references if you're not going to use it in any way. I don't know how you feel about it.
Sorry, you mean changing things to references if we're not going to use the new memory?
Yeah. Is it still worth, you think, going through the effort? Because there's a lot of places and it will be a dependent change. Like you change, if you change, for example, the return type of comp arrow allocator, that breaks a whole bunch of code that you have to change at the same time. The majority, I believe, is in OMR, but there's like one place in OpenJ9, and there might be others in extending projects. So it's one of those things where when you change the return type of comp allocator, it affects quite a lot. Same with the raw allocator. You actually have to, and if you look at the way I had to do it, it's a little silly, but in order to make the raw allocator a reference, I first had to instantiate a raw allocator on the local, then use that raw allocator to allocate another raw allocator, which is a pointer, and then have that pointer be the reference because now it lives dynamically. Otherwise, it would be on the stack and would die. Whereas before, it didn't matter because you could just pass them around. So the one thing that we have to do here is better understand lifetimes of some of these objects, which we didn't care about before, but we should. And the TR allocator is a question that just I don't really know why that's the case. Why do we even have one in the comp object if we're going to pass it by value? I have no idea.
Yeah, it's weird. It looks like TR allocator right now points to what's effectively trying to be a reference wrapper. It's very strange. Not sure why.
But except it's not, because it'll create a new one, right? Like I thought it didn't matter at first, but it does, because if you look at the CS2 allocator, it has it resets a bunch. I think it does it has buckets, I believe. And every time you create a new comp allocator, new buckets. And that might have changed the performance characteristics. Like if we switch to only using one, the various buckets are all merged into one. I don't know what the consequence of that is. So that's why I didn't do it. I left it as each one gets their own version. Now that's kind of expensive, but and we actually it's kind of ridiculous because we're passing these to multiple functions will pass them along. So we're constructing and destructing this thing like crazy just to get one of these guys sometimes. So
yeah. I don't know. I need to look at this further because it looks to me like it's just a reference wrapper. So it's not actually like when you're copying it, it doesn't look like it's constructing anything new.
okay.
That it's a very bad reference wrapper because it itself has a field that is reference. I don't know why that was done.
Okay, if you can take a look and let me know.
Yeah, I'll take a look into that.
Because if it is the one I'm thinking, it's pretty bad. It makes no sense.
Yeah, maybe it's overridden somewhere and I'm not seeing the override here, but it looks like it's just a reference wrapper.
Which actually, at least then it's a bit better because there's
Yeah.
only one of them. And that.
In that case, the new TR allocator could just be a reference wrapper
yeah.
or the new segment allocator.
Yeah, I don't know if anyone else has time to look and have any other questions.
So assuming, let's assume that this is something that's going to work and it's going to meet our needs. Is it? Could you put together sort of a transition plan from where we are right now to all the steps that we need to accomplish along the way to get there?
Let's talk to these guys in terms of their
Right.
idea.
I don't mean necessarily you, but with your sidekicks.
Well, we're sidekicks.
Deputies.
I have an OMR committer as a sidekick.
Yeah, I mean, just so that because we can potentially stage it, if we can do a lot of this stuff completely independently of actually somebody doing the entire thing, right? We can give some of this work out to, the changing all those values to references, for example. Right? So, but just so that we have an idea in our mind and throw in when would be a great time to do performance analysis and that kind of thing. So.
Sure. One of the things I wanted to get out of this was that this right now is a one-to-one mapping exactly with the way things are as they stand. I wasn't sure if there was a desire to change that a bit or not. In terms of right now, every single allocator will do exactly what their one-to-one mapping does. Whereas before we were saying, we could split it so that every allocator has its own policy. Maybe it doesn't make sense to do that because you're delegating too much. Maybe some policies should be merged. essentially what I wanted people to look at and see this is, now that you have a consistent API, does it make sense to break up things or not? You know, and I'm not
would it be
saying,
easier to do that? Sorry, is it easier and less error prone to do the one-to-one mapping first, and then once you get there, then
Yeah.
make your changes? Because
Yeah.
I'm worried about changing too many things at once.
yeah,
And actually, this kind of goes back to my previous thing about the transition plan, because the one thing that I would really not like is if we started on this path and then we gave up on it. So we would have yet another set of memory allocation, this other apparatus in place that is partly used, maybe, and we've got this other stuff. So we're left with this in an incomplete state again.
no, I think this one is one of those things where you could never partly use it. It would have to be one or the other. Two fundamentally different. Like you wouldn't be able to build it if you tried doing it.
Fair enough.
So at least you have that. If we give up, it'll be given up but not used at all. So. But I can talk to Ben and Leo and come up with a plan.
Okay, good.
For the question of like, do we re-architect things so that there's more delegation or whatever going on? I feel like that's almost like a per project decision, right? Because part of the point of this design is that OMR just deals with everything through these interfaces, and it's up to the users to decide how they compose these various allocators together. So I think that's almost like just up to downstream projects to decide how they want to use those interfaces and how they want to split things up.
Fair. Do we, considering that like some of us are also OpenGI committers here, do we need to have an equivalent discussion with the OpenGI compiler side now? Like if, let's just say OMR decides to go for this, how, like, what is the process? Like what?
At the very least, you should have an issue open, I guess, in OpenJ9, so you can have some kind of a discussion there. Yeah.
Like for the most part, it's us because we work on a compiler and very few people who work on the memory stuff.
It's going to be the same people in this room and on this call that are going to be involved in that discussion, but just for transparency purposes, you should probably do that. Yeah.
You should certainly work out what the like at OpenJ9, I think you should discuss what the transition plan would be, what the effect would be of OpenJ9 not moving to the new memory design. If they could make that choice, if they can't make that choice, then OpenJ9 compiler community needs to make that choice.
I mean, they can take, what is it, like one or two things from OMR and move it to OpenGNet,
right?
As it is, and then the impact would be pretty small, I think, if they choose not to.
Or
Now,
hopefully they won't make that choice.
The impact in terms of what you want to do with Trill and JIT-Builder would be pretty massive because you wouldn't be able to, you would have to then implement the allocator that Trill and JIT-Builder wants.
Yeah. Like I said, I hope they won't make that choice. Have you, let me back up. What testing have you done on this so far? Is it like PR testing or?
No, not even that far. I sort of got very basic Java tests running, and then I ran another benchmark that did get to hot. So I did see that like more memory was used. I didn't go super crazy because I was like, there's decisions made in here that I don't completely agree with anyways. So I figured for this particular meeting, I didn't bother. In terms of, and the reason why is because there's, it's very much a one-to-one mapping. There's, I think, maybe two places where it's different. Almost everything else is exactly the same. The two places are how we allocate from the JNet memory segment, okay, which is scary in of itself.
The classes that you built, not composable classes right now, right?
Not right now.
They're
I
in the
didn't-
test log
Yeah, I didn't.
space. Right?
If you look at it, I have to explicitly, include OMR test whatever and J9 test whatever, only because I don't fully understand how to build an extensible class from scratch. And I was like, you know what? I don't want to copy an existing template and then restart all the things. So like, again, I tried to minimize the amount of.
I got it. But presumably that would be the way to do this for real, right? And OMR would provide a segment provider, system segment provider class, a segment allocator interface.
So I don't know if it has to be extensible.
I don't think it needs to be extensible.
It might be for, so I was thinking about this, and I don't know how, like, if we're going to make anything extensible, the only thing that can be extensible is the API class, the one that's the abstract class. Nothing else after that should be. And the only reason for that is in J9, we have just extra queries of, how much system segments were, how much system memory was allocated, how much region memory and preferred segment size. So I just put all that in OMR. No one in OMR uses it, and they put like a tier assert in there that says shouldn't be calling this version of the thing. But those were all API, like top level, and so
that's another simplifying assumption here. Okay.
so there's two approaches there. One is you make that abstract class extensible. The other approach is that J9 does something where it creates a second abstract class below it, sort of what like Luke did with segment provider and segment allocator, where segment provider only had request and release, and the segment allocator had the remaining things. Again, the reason I didn't go into all this is because I was like, these are things to discuss for the actual design of the real way.
Sorry, are those extra queries you said that are only used in OpenJ9? So the reason right now they're defined in OMR is so that they're defined on the interface class.
The reason I did that was because in J9 we passed the reference to a few functions, and if I could change it to be the one that I know it is going to be, but the whole idea was if we change that in the future, change all those places.
Okay.
Maybe it's fine. I just, for simplicity, I sort of said.
Okay, no, fair enough. Because I was trying to understand why they had to be in OMR if they weren't used in OMR.
It was literally just for the API reason. Other than that, and like you said, there's different ways of doing that. That's up for debate. I'm not wedded to any one of them.
Yeah. So at this point, we wouldn't actually be able to test what you've done here as for something like dictionary method building.
We could. The way you would do it is either the way I put in the comment above, which is create another class that has the same name in J9 and OMR. And in OMR, you compose it one way, and J9, you compose it another way. Or we extend it so that we pass in an allocator to it. And then but that could work in the current approach also. The same thing works both ways, really. Even in the current one, we could create another class that has the same name that extends from system segment provider. And, if you use the compiler magic, we'll just map to the right class. And it'll do all the right things.
Remind myself how this works.
So the type dictionary and the method builder take in a system segment provider. There is a OMR system segment provider. There's a J9 system segment provider. They have different constructors because they're not extensible.
Where are they getting it from?
They are just created like in there itself, like in the type builder itself. They're not getting it from anywhere else. So the two approaches are encapsulating class or pass it in.
It can't be passed in because you don't have one to pass in.
Well,
Have a default one.
We mean a default one.
Right.
But something has to create that default one.
Yeah.
So who is that?
Well, it can be JIT builder, Trill, or it can be the user, and then the user constructs one to pass it in.
Okay. So for JIT builder, it can't be the user.
Why not?
Because I don't want them to.
Yeah, I imagine we don't want to be leaking all these API
JIT builder is supposed to be
details.
independent of the OMR compiler. I don't want the dependence on the OMR compiler for JIT builder.
So for something like J9, where we already include all the memory stuff, wouldn't it make sense there to be able to construct it as
Sorry,
allocator?
I missed the first part of what you said, sorry.
One of the big reasons you didn't want to pass in an allocator is because you don't want any users of JIT Builder to include all like more compiler headers than they need to.
Yeah.
But when you were making it work with J9, since we include compiler memory headers and a whole bunch of stuff anyways, in that particular scenario, wouldn't it be okay to pass in an allocator? Like
the J9 case is different, yes, you're right.
So like I think it's only like we have the default one, and then I guess the only problem there is that anyone who is not in one of those two worlds who wants to have a different allocator but doesn't want to include the compiler would have the problem where they're forced to use the default class, unless we say everyone has to create a class of this name, and then that'll be your encapsulated class. So,
well, I mean, there is a use case for JIT Builder that doesn't have the OMR compiler in the library, right? We don't currently support that, but that is a direction that I'm trying to move things in. I'm trying to talk about this at one of the next, I guess the next one, the next architecture. Yeah, so that's all right. I'll foreshadow a little bit.
The trailer.
The general strategy there is I'm trying to turn JIT Builder into a compiler infrastructure of its own, which operates above the OMR compiler. So the OMR compiler becomes kind of a back end for JIT Builder, but you can actually work with JIT Builder itself and manipulate the JIT Builder services that you call as an intermediate representation. And in that scenario, the output of that process could be just a persistent form of the JIT Builder IL and not actually even invoke the OMR compiler anywhere. So, so that might not intersect with what you're talking about, because the place where you need the compiler's memory allocator is in the OMR JIT Builder implementation files, which you wouldn't have in that scenario.
But I guess the question becomes, do you envision any users of that wanting their own memory allocators to be used instead, right?
Okay. I think I have an answer to that. Not being able to read Mark's mind, but
I wasn't worried I'd ask a question.
Yes, Mark is right. I can put pieces together of what he's thinking. So if the OMR compiler right now is just as a backend, right? So when JIT Builder is in a mode where it uses the OMR compiler, it would have to provide the allocator the OMR compiler will use. Now, that allocator does not need to be the same as the one that JIT Builder is going to use. So JIT Builder can have its own separate way of providing custom allocation mechanisms to the user, or it cannot. That doesn't really matter. It's going to be whatever magic in the implementation. When it's using the OMR compiler, it is going to wrap whatever it has in a segment allocator and a raw allocator and pass that to the OMR compiler.
So essentially what you're saying is that if the user, if you have an API where you tell the user, give me your allocate and deallocate functions, then it'll construct the segment provider such that it uses the user's ones. The user doesn't provide the two allocate and deallocate function pointers. It'll use
its own default one, and when it hooks into the OMR compiler, it will pass those along through the interface we set up for the OMR compiler.
That's fair. I mean, especially
so you're trying to think further down the line from where I am. So
3.0.
You're ahead of me. Yeah.
In 4 weeks.
No, that's 2.5.
Essentially, that fits into your custom allocator notion.
But I mean, in in general, like not using the OMR compiler as a backend means not using the OMR compiler memory allocation infrastructure even, right? So at that point, it could be, doesn't have to be, in the prototype that I've written you're just allocating stuff with C++ new and delete wherever you want, right? It's not even using special allocators to do things, right? It's more the use of the OMR compiler allocator framework should introduce itself when the OMR compiler becomes an essential part of the story, and it should not impose itself on the rest of the story. It's my basic position there. But I don't think that's very hard. Like having thought a little bit more about it while I was talking, I don't think that's actually a big issue.
The nice thing about this design is that in terms of that, the system segment provider and the OMR compiler right now takes in a malloc raw allocator.
Mm-hmm.
It would be trivial to just say take in the custom allocator, and all the rest of the code would be exactly the same actually. So.
And that's one of the benefits of using this interface approach is the OMR compiler won't care where stuff comes from. And if JIT Builder doesn't want to use it, it doesn't use it.
Right.
We haven't had a discussion on the compiler API in quite some time for version 0.2 or 1.0 of, but I would imagine that where this is going should be part of the compiler API. Yes. So
Where this is
the
memory allocator.
The memory allocation interface and how it's excluded. So. We can give.
Might even be a good place to start.
Well, yeah. That's where I was going.
How do I get memory? All right. Figure that out.
So with the compiler API, is that something where you have to expose the compiler header? Like if you wanted to use the compiler API, you're building with compiler headers there, or is that something where you're still?
Well, compiler is OMR compiler in this conversation, right? So I mean, all the other. Maybe not all the other, certainly most of the other compiler, most of the other components in OMR have a notion of a public API that they expose and that they expect people to program against. Maybe some issues with those public APIs, and not all of them are stable, etc., but they have a notion of a public API. The compiler right now, we haven't documented any real notion of a public API for people to build compilers using our infrastructure. Principle, everything is open season on APIs and classes inside the compiler, which is nice from a flexibility standpoint, but not great from a what am I allowed to do, what should I do, how can I do this, what are the right things to do.
Oh, you mean like in terms of things like init the compiler and set up the stuff in order to call compiler, not compile, and all that kind of stuff?
Oh, if I'm going to write a compiler using the OMR compiler, what do I have to do? What are the things I have to change? What are the things I have to hit? What are the public integration points that I need to hit?
I see.
And if that story is, well, you go inside a systems provider and need to do a raw allocator, but don't do this and it's that thing, and you can dork with that thing if you want. Like if it's a complicated story like that, then no one's going to come forward.
Yeah.
But if we can start to build up some documentation and real actual like raw allocator has this API, implement this, and poof, your compiler will be able to allocate memory, et cetera, for the set of classes that you need to implement. Then all of a sudden you've got an API that people can actually look at, read about, and have some hope of being able to interact with.
Right.
So we need to do better on this work. Or as a general rule, we've done a lot of work trying to make things accessible and so that you can actually implement compilers on top of the OMR compiler framework, but I think it's still kind of very difficult for someone to learn how to do that without sitting on this floor of this building and soaking in it for a year or two in our team, which is not great for an open source project. Right? We need to do better than that.
then maybe as part of our roadmap plan, we can also formalize the APIs.
Yep.
For this particular part.
Yeah, I think
That would be very nice.
Yes.
Oh, I had another question. I can't remember what it was. Any other comments on this? The next steps are somewhat clear for putting together the next steps are the next steps.
Should say one of the other things that having a defined public API allows us to do is to document changes that are happening in the API that are going to affect downstream implementations, which is something that we have no way of doing right now.
Okay.
Basically, anything can change underneath you. Not everything does, but lots of things do stay stable. But
I have just one quick question. When, in your third point, you said that that constructor that in J9RA that takes a const raw allocator reference, is that just because you haven't gone through and changed all of the all of the pass by values to be pass by reference? Or was there another reason for that?
It's because I copied raw allocator as it was, and they had the same copy constructors. And so I was like, I don't know what are all the places that might implicitly have this thing.
Yeah.
I believe now I've fixed maybe now that I've fixed everything to return by reference, maybe this isn't a problem anymore.
Okay. Because when we were talking, I thought that was originally the reason you needed this.
I think maybe it wasn't at that time.
Yeah.
Or maybe I think at the time we were talking, I don't think I'd even gotten around to building it.
Right. Okay.
But I saw the copy constructor, and then I was thinking about it going, if we're only ever dealing with a API, like a raw allocator, the reference, how is the compiler supposed to know which copy constructor to call? But maybe we don't need that copy constructor anymore.
Yeah, well, because
that's an aspect of the problem that I ran into when I tried to move to when I tried to introduce a virtual hierarchy.
So that's why I had that ugly reinterpret transfer. I'm like, well, you know what you are.
My understanding was that if we're passing everything by reference,
it doesn't matter.
We're never copy constructing anything.
Maybe I can just remove the copy constructors and see what happens.
Okay. If it needs to be there, that's fine. Just need to know why.
I imagine now that I think about it, but again, that's one of the things.
Yeah.
There's a lot of things I've glossed over that need proper explanation.
Yep, that's fine.
And that was sort of the whole point of this, was just to get something.
Minor nit. Use of J9RA makes me read register allocator everywhere. Yeah, it's really hard to read. I have to reprogram my brain.
I mean, we can easily change that to J9 raw allocator.
It's a minor thing. It's just that.
The reason it was there was because in that design doc we put J9SA, J9RA, and then I was like, you know what? I'm lazy. I'm just gonna write it.
Yes, that's the summary. Thanks for some amusing reading.
Okay. Any more questions or discussion on this topic before we adjourn? Nope. Okay. All right. Thanks, Erwin. And I guess we'll adjourn and convene again in 2 weeks. Okay. Thanks, everyone. Bye.
Bye-bye.